Hello and welcome to Calculus tutorial. We are continuing to look at limits, and with this video we're going to take a look at how to evaluate limits analytically. So we're not going to prove the limit exists, we're going to figure out what the limit actually equals just by using algebra. And there's four ways that we are going to do this, and with this video we're going to take a look at three of them. The easiest one, the one here at the top, dividing out, I'm hoping you saw in trig, but if not, this one is really easy and is the first one that you usually want to try. And so here we have the limit as x approaches -3 of this big function. And we're not going to test it, but if you did try to plug in -3, you would get 0 in the denominator. So we can't do that. And so we have to do something else. And so what we do is we factor the top and the bottom. So the top, what multiplies to be 12 and adds to be 7, +3 and +4. And on the bottom, what multiplies to be -24 and adds to be -5 will be -8 and +3. And once you factor them, you'll see that there in the top, there happens to be an x plus 3 and an x plus 3 in the bottom. So that means this technique is going to work because those two terms cancel out. We're left with the limit as x approaches -3 of x plus 4 on top and x minus 8. Now what that did was getting rid of the x plus 3 factor means that plugging in -3 will no longer give me 0 in the denominator. So now that this limit is simplified, we can actually simply plug in -3. So -3 plus 4 is 1, and -3 minus 8 is -11. So our limit is going towards 1/11. Definitely the easiest technique, I would say, and the first one you want to try if possible. You factor it and hopefully something cancels out. Okay, so that is the dividing out technique for evaluating a limit. Two more for us to take a look at. The next one you might want to try is multiplying by 1. This one's a little bit more difficult. And you often want to try this one when it looks like you can't factor anything. So obviously nothing to factor here. If we want the limit as x approaches 4, we definitely can't plug it in because we get 0 in the denominator. So we have to try something else. And what we're going to do is multiply by 1. But not just 1. We're going to multiply by the conjugate. Okay? The conjugate of the top. So we're going to multiply by the square root of x plus 2. That is the conjugate. But of course, if I'm going to multiply the top, we also have to multiply the bottom. That's how the conjugate works. And you can see the same thing on the top and the bottom means we are, in fact, multiplying by 1. So we're not changing anything. Alright, so the limit as x approaches 4. So now we have to multiply the top. It's a little tedious, but it's not that bad. So the square root of x times the square root of x is just x. The square root of x times 2, and then -2 times the square root of x, and then -2 times 2 is -4. Now hopefully you see something interesting happening here. The middle terms are going to cross out. And we did that on purpose. That will always happen when you multiply by the conjugate. You essentially get a difference of squares. the fact that this is plus and this is minus, means these middle terms will always cancel out. Always, always cancel out. We're sort of forcing that to happen. So you can kind of take that shortcut possibly, but just make sure you recognize why those middle terms go away. And the nice thing is the denominator, don't multiply the denominator. Just keep it the way it is. Put parentheses around everything to keep it clear and separate. Keep it that way. Because just like the dividing out technique, our overall goal is to cancel this term out. That way we can plug in 4. So don't unfactor this. Keep it factored, and hopefully it will cancel out. And you'll see right now that it obviously will. So the limit as x approaches 4. So the middle terms cancel out. We are left with x minus 4 on top. And on the bottom we have x minus 4 times the square root of x plus 2. And so now you can see that we have an x plus 4 on top and an x plus 4 on the bottom, and those do cancel out. So we are left with the limit as x approaches 4. On the top there is still a 1, so make sure the things that are in the bottom stay in the bottom. And the square root of x plus 2 is left over. Now that we got rid of that x minus 4 factor, we can now plug in 4, no problem. So plug in 4, we get 1 over, the square root of 4 is 2, plus 2 brings us back to 4. So this limit is equal to 1/4. So that's a powerful strategy there. The conjugate, it's the exact same thing as the top, only you change the negative to a positive. It's called the conjugate. Alright, that's our second one. The third one is what students have the most trouble with, but it's the one where you're actually going to have to do the least. But it is a little confusing. It's mostly a conceptual idea, not an algebraic one, and that's oftentimes where we have some trouble. So we've got the two algebraic methods out of the way. Now one that is just sort of a thought experiment. It's called the squeeze technique. Okay, so here we have a limit as x approaches 0 of x squared times cosine of 1 over x. Now if you try to plug in 0, 0 squared is 0, times anything else, you would think that would also equal 0. But if you plug in 0 into x down here, you get a 0 in the denominator. That is undefined, and so we can't say for sure what's happening to this function. And so we have to do something else. And hopefully you can see factoring's not going to work, the conjugate's not going to work, so our other two methods don't really help us. So we need to do something else. So I've got a graph here of that function. And it does definitely look like as we get closer and closer to 0, we get closer and closer to 0 for the y values. But again, we can't say for sure. What if it never actually converges? What if it keeps bouncing? As you can see, it's bouncing. And so what we do is we squeeze it between two easier functions. So we have the equation x squared times cosine of 1 over x. And what we're going to do is that function is always going to be smaller than x squared. Cosine bounces between -1 and 1, so the biggest cosine can be is +1. And multiplying by 1 doesn't change anything, so it will never get bigger than actual x squared. So take a look. Do you see how x squared is always right above it? Every once in a while, they touch because they can be equal to each other. When cosine is equal to 1, this is just x squared. But then cosine gets smaller than 1, and so it brings the graph down. It brings the graph down. And then we have to sandwich it on the bottom as well. And so this graph will never get smaller than -x squared, because cosine can only get as low as -1, and that will just turn the x squared into -x squared. So that is our lower boundary. Take a look there. Definitely fits nicely. And then what we need to do is, now that we have two equations that we know about, we know how these two behave, we can use them to figure out what is happening in between them. So the important thing to visualize here is our function f is always smaller than this one, but always bigger than this one. And so here, algebraically, is how that works out. Okay? So we want to know the limit as x approaches 0 of this function. I actually might even get rid of the limit first. We know that this function is always bigger than or equal to negative x squared. But it's always smaller than or equal to positive x squared. It's sandwiched in between them. And so what we do then is we take the limit of all sides, the limit as x approaches 0. If you do it to one side, you have to do it to all the others. We don't know what the middle is, but the other ones are nice and easy. As x approaches 0, x squared, negative x squared, goes to 0. Same thing with the other side. Positive x squared, as you get close to 0, also goes to 0. And so in the middle, squeezed in between them, is still our function that we're interested in. And so if this limit has to be bigger than or equal to 0 and less than or equal to 0, the only option is that it is actually equal to 0. So the limit as x approaches 0 of x squared times cosine of 1 over x. Oops. Let's make that a better parenthesis. Must be equal to 0. And so that is just a logical statement that says this limit is being sandwiched in between two other limits. And I think you can sometimes see it called the sandwich technique. I like squeeze technique a little better. But all right, so we got three options now to try to look at limits. And next time we will take a look at the fourth one. It's important. But we've got three good ones. By far the two most important are the dividing out, that one's the most popular, and the multiplying by 1.